also we are using this kind of vehicle system. So details of actual a vehicle system. So actually all these are we have discussed yesterday. So still we will recover here. The engine, including lubrication and cooling. The fuel system, which include evaporation and emission system. In case of that petrol fuel or combustion fuel, but in electrical system that won't be required. Then ignition system for charging the or for propelling the vehicle. Electrical system, including starting and charging. Then exhaust system, including emission control. Drivetrain, which include the transmission and those kind of system, gear system, etc. The suspension and steering system for giving direction to the vehicle. Then the brake system, frame, and the body. Yeah. So this is a kind of infrastructure or infrastructure for making or for getting a structural design for electric vehicle fuels. But there are drawbacks of pure battery-based electrical vehicles also, because if we are completely relying on only battery-based electrical vehicle, there may be a chance. There may be a chances of getting battery degradation due to overload condition, that battery will going to be destroyed or it will going to be decrease in efficiency due to sudden accidents and due to sudden impacts on that batteries. There may be a chances of getting blast. And whatever the batteries we are using in current days, those are having a liquid electrolyte in that. So due to that liquid electrolytic solution, if it is mixed with that any other chemical composition, so it will going to be having chances of getting blast. And there are very much restrictions for removing those battery from the electric vehicle which is being used earlier. So we need to go for some hybridization, so that whatever the load on only one energy storage system we can reduce, and simultaneously we can use both energy storage system in one electric vehicle. Research is going on. Definitely we will get some fruitful solution. Limitation of Asian countries for EV batteries. Okay, that's the major problem for this, because if we are saying lithium ion battery, we are going to be most dependent on electric vehicles. But whether whether we have those much storage or those things at our Asian country, so answer is no, because only 1600 ton has been recovered from Karnataka, and one of the organization is there, that NREL, I think, I don't know the long form, but NREL organization of India, they are started capturing more and more lithium or comparatively other material like cobalt or nickel in some MP sites and those kind of those related nearby area, Andhra Pradesh and Madhya Pradesh. So so that we can get more amount of metals which can be used in batteries, and we should we can go for some further better suitable comparative solution for lithium. So types of battery used in electrical vehicles. So definitely lithium ion battery is the most suitable solution for current days for electrical vehicles, but it has many disadvantages also for degradation and for recycling purpose. So we have to move for some better solution, like zinc ion is there, and sodium is there, aluminum battery is there, because we have in India we have tremendous amount of storage of aluminum, so we can go for those kind of solution. So we need to focus more on those kind of batteries. HEV market drivers and technology trends. Here we can see very only very minute Indian manufacturer companies has gone towards actually electrical vehicles. So different level of electrification exists in answer CO2 degradation target. So you can see here, Toyota, they are also going for fully hybrid electrical vehicle. Mild is a fully hybrid electrical vehicle. This is Nissan, they are going for only pure battery electric vehicle and full electric vehicle. This is Mitsubishi Outlander. They are moving. So many if you will see comparative table, CO2 emission for CO2 fuel efficiency and CO2 reduction benefit are continuously increasing with the level of electrification. So as we will go more towards hybridization of electrical vehicle, definitely we will get a good solution. Among that, fuel cell electric vehicles are a good solution, but to control that hydrogen reaction in fuel cell electric vehicle is somewhat a cumbersome or difficult task. Next, electrified vehicle market still has to overcome some difficulty to know the full development. Okay, that is battery dependency. Price of electrified vehicle is often prohibited for user. With technology continuously improvement and volume decreases, definitely when we are going for further improvement in battery technology, it will increase the cost of that manufacturer, and that cost will going to reflect on the customer, and customer will definitely move back from the electrical vehicles. So we need to have some fruitful solution for battery as well as the meeting customer demands. Battery cost and autonomy is still big obstacle. Battery cost and autonomy is still a big obstacle to the market advancement. The same sentence, with regulation coming from the government, charging solution should quickly come to a standard and infrastructure should develop a lot. You can see there are very rare charging station are started in Indian countries. So we have to government has to focus more for improving the charging station and suitable charging mechanism for fast charging as well. Okay, so from 2010 to 15, electrified vehicle will remain with the modest growth except for stop-start vehicle. Stop-start already enter a most and generalized car maker fleet. In next year that SSV will going to be more discussed on that electrical vehicles. Okay, so this is somewhat a graphical chart for this is taken from that one of the research papers. Here, some technical difficulties and been considered over here. The wattage amount of that electric vehicle that has been considered, power assembly architecture, converter topology for low voltage electric vehicle and high voltage electrical vehicle. Inverter has to be developed according to the electrical motor. Then passive element, high temperature capacitors, then enhanced cooling of the power converter. Then power packaging will have to improve, and wide band gap semiconductors for super capacitor that will have to improve. This is somewhat power assembly technologies which are being going to be increased according to the only for engines. Okay, so these are like direct cooling, double-sided cooling. These are the modifications given for in terms of mechatronical development for the IC engine-based vehicles. Now, power module packaging technology for batteries. Here we can, whatever the different types of companies are shown here, Denso company is there, Toyota company, Honda, Delphi, Bosch, Mitsubishi. This company has developed high frequency cooling system with integration to the battery for further modifying the electric vehicles. uh, Okay. Next is, yes, intrinsic property. This is related to thermal cooling system for the electric vehicles. So high electron mobility, no recovery time during the switches, and low losses at high switching frequency. Less cooling needs will require. So high junction transformation, if you will provide it, cooling will be required less, and we can improve the efficient solution for the electric vehicles. Now, many are the customer relationship issue that we'll have to face. So charging infrastructure. By comparing with the government, we need to improve it. High price of electrical vehicle. So this high price of electrical vehicle is due to the battery. So because in the current situation, batteries has been imported from the countries like which are rich in that lithium, like Chile, Ghana, China, etc. So they have a tremendous huge amount of lithium. So still we are importing those lithium from those countries. So prices are going to be increased. But whatever the different types of metal are available in respective countries, if they will focus on those metals to make the batteries from those metals, so definitely that cost will going to be reduced. Range annexity. We can't use or still there are some limitation for electrical vehicle to run that electrical vehicle for a longer range. It will so for that we can improve some cooling media like thermal cooling, and there different types of further coolings also. So we can improve that range annexity. Same policy flip flop for the government rules and regulation. Charging infrastructure. For improving this inadequate charging infrastructure, we can implement IoT. That will be the best solution that we will discuss in further slides. Reliance on battery imports. So different types of batteries, if we will modify, definitely we will not rely on only one single battery. Reliance on imported components and parts, definitely that is the biggest issue actually for a customer, because still Indian like country or Asian country are dependent for many electronic parts on China or Japan. So those components prices are very less, but that will be a very what we can say vital, that plays a vital role for creation of that electronic circuits and electronic design. So, so for that, we need to improve those things. So dependency of on electronic part from the sectors. So next is high prices of EV in current situation. The same point we have discussed. Lack of option for high performance electrical vehicles. So for that, we need to improve the hybridization. Hybrid electrical vehicle technology readiness levels. So readiness level in the sense ki what are the different types of battery technology we can modify, that will be a good solution. So different types of batteries available like nickel, lithium, sodium nickel chloride. So we have to go for such a kind of battery which we can recycle again, or there will be a very less cost investment for recycling purpose. So that will be a good solution. Then the prospects are battery management system. So battery management and to control the structural and thermal issues to that batteries, we can incorporate. So the prospect for it is a battery management system. We have to go for some good electronic solution for battery management system, so that we can control that overcharging and thermal runaway issue. Electric motors, we'll have to reduce the size of electrical motor, because as the size of electrical motor will increase, definitely it will impact on the efficiency of the electrical vehicles. So for that, we have to focus on like BLDC motors or kind of different energy storage system in hybridization. Power electronics like sensory mechanism, data acquisition system, that we have to focus much more to input that IoT system in the situation. Yes, we can input that AI system also in this hybrid technology, hybrid electrical vehicle. Using that AI technology, we can more AI and that IoT, we can more modify that electrical vehicles. Weight and aerodynamics. For this, we'll have to focus on vehicle dynamics parameters. Range extender, for this we'll have to go for some thermal cooling and those kind of situations. Super capacitor, we have to do some work on modifying the discharge time of super capacitor, because we know the highest amount of power density component is super capacitor, but it discharge in very less time, in either sometime it in a second or in a millisecond. So if we can control this time of discharge of super capacitor, I'm not saying that we can increase. We can't increase that discharge time. We have to control such a kind of mechanism that supercapacitor discharge time can be reduced. Then we can further charging station. We need to improve. Elements of vehicle dynamics. Now, when we are saying ki we are going to design or structural design or structural optimize that electric vehicle, so we must know the different types of forces act on the vehicle and the vehicle dynamics. So vehicle dynamics is related to some kind of forces. So in vehicle dynamics, vehicle body, the mass, the suspension component like damper and spring and tire, the unsprung mass are essential part of the system. So basically, the vehicle dynamics include three major parts like vehicle body, suspension system, and the tires. So when we will in afternoon session, we will design that complete electrical vehicle with the that Simulink. You will know each and every aspect of this. Factors affecting vehicle dynamics. So the factors affecting vehicle dynamics are drivetrain and braking system. Yes. So for that we can go for some regenerative braking system and we can modify it. Suspension and steering. Yes. Distribution of masses. So mass distribution on whole body, how it is going to be distributed. It should be equally or according to the situation of the operator or the driver. So we have to finalize some kind of mechanism for this. Aerodynamical issue to increase the speed of that vehicle. So definitely we'll have to focus more on aerodynamical issue. Tires. So we need to find some fruitful solution for tires as well. Now, as I told earlier also that there are different types of software for analysis purpose, like this and before manufacturing those systems. So those are like Adams is there, Modelica is there, Carsim is there, and Simulink is there. So for among this software, we are going to see this Simulink in the afternoon session. Let me check whether I'm audible or not. Yes, yes, I'm audible. Yeah. Dynamics of the sorry. Dynamics of the motor vehicle. It is a combined study of interaction between driver, vehicle, road, and environment. Okay, that is the major definition for this motor vehicle dynamics. It mainly deals with the improvement of active safety and driving comfort and reduction in road destruction. The acceleration of the vehicle depends upon power delivered by the propulsion unit, road condition, aerodynamic shape, and mass of the vehicle. So for all these parameter, we have to design the proper location, or what we can say the proper component sizing of all the parts related to that electrical vehicle, so that we can modify the shape accordingly, so that shape will get good speed by improving the aerodynamical parameter, good propulsion unit, so that we can, if we can reduce the battery size or battery pack size, the propulsion unit can be improved. And for road condition, definitely we'll have to depend on government side. Next, general description of the vehicle movement, like tractive forces, rolling resistance, aerodynamic drag, and uphill. Uphill, many times it is called as a grading and acceleration resistance. Longitudinal vehicle dynamics. There are two types of vehicle dynamics actually. So longitudinal vehicle dynamics, where we are considering forces and motion in longitudinal direction only. Smooth road surface, predicting top speed, acceleration, braking performance, gradability. Here the term gradability in the sense ki, how we can move in on the inclined roads, like the capacity of moving the vehicle on the inclined roads. Then fuel consumption. Lateral vehicle dynamics related to force and motion, mainly in a lateral direction, predicting the cornering performances. Cornering performance like turning or those kind of operations. Handling and stability. Stability like the balancing issues. Vertical vehicle dynamics like forces and motion, mainly in vertical direction or ride or vibration behavior, tire roads, etc. Okay. Forces acting on the vehicle. Now, which are the different types of forces act on the vehicle? The first one is the gravity force. So, for mechanical students, this is not a new actually. So, because we have learned this in a theory of machine and many kind of related subject. So, gravity effects are there. Then aerodynamic forces are there. Right, tire and road conditions are interactions is there. Tire behavior, longitudinal and side slip, the dynamic equation of vehicle motion along the longitudinal direction. Then performance parameter which we need to consider for the better electrical vehicle, that is acceleration, top speed, gradability, which I discussed, that capacity of on the move on the inclined roads, then braking performances and adhesion. Yeah. So, what are exactly the forces acting on different components of the electric vehicle? Components in the sense like driver, load, and etc. So, driver will going to be affected by lateral dynamics and longitudinal dynamics of the vehicle. So, where driver will going to be focused on steering of the wheel, acceleration for braking, brake pedal, clutch, and gear shift for moving the vehicle. The vehicle provide the driver with this information. Now that what vehicle will provide information to the driver. So vibration, longitudinal, lateral, and vertical, all three. Sound, of motor, aerodynamics, that car sound, then tires, etc. Instrument, velocity and external temperature. Ki, in some cases, that distance also can be calculated. Ki how much distance we can cover with the so much charging or that much charging of the battery accordingly. The environment also influences the driver, like climate, traffic density, and track. What now? Environmental factors. The environmental factors are road, irregularities on of the road, like uneven surfaces of the road, coefficient of friction, then air, that resistance, crosswind, etc. But also affect the driver, like environmental climatical changes and visibility. Visibility, like if there is a fog and those kind of situation, definitely that will affect on the driver. So we need to improve some kind of sensory mechanism or wireless sensory mechanism to identify the fog, and then we can move ahead. Using IoT, it can be possible. Load. So whatever the different types of load act on the vehicle, that is a mass, inertia, center of gravity, dynamic behavior of the vehicle. So these three factors we need to consider while designing any kind of vehicle. So right now we are focusing on electrical vehicles. So for electrical vehicle also we need to focus on these three different factors. Now, next is uh, vehicles. So there are different types of vehicle like motorcycle, passenger cars, buses, trucks, and agricultural tractors that we are going to that we can see on the concept. Hmm. Vehicle coordinate system. Now, what is exactly vehicle coordinate system? Vehicle coordinate in the system in the sense ki many times we have heard one term, that is local coordinate system and global coordinate system, or machine coordinate system and user coordinate system. So when we are considering those terminology like machine coordinate system and user coordinate system, it means one is related to the fixed machine and second is related to a movable worker. So according to that, then local coordinate system and global coordinate system, when we consider, that is related to some kind of FE analysis. So where we need that local coordinate system for movable, and this global coordinate system will be a fixed. So similar terminology has been used over here, that Earth coordinate system and vehicle coordinate system. So actually, we know that Earth is actually we are assuming as a fixed, and vehicle coordinate system we are assuming as a movable. So here we can relate that Earth coordinate system will be a fixed coordinate system or a global coordinate system, and vehicle coordinate system will be considered as a movable coordinate system or a user coordinate system or a local coordinate system. So Earth fixed coordinate system is there based on Earth fixed axis in which origin is fixed on the ground plane. Okay, it is has a base that on which basis it is fixed to the Earth. This axis system is fixed in the initial reference frame where x and y are parallel to the ground plane and z point upward aligned with the gravitational vector. So this casual approach actually, ki we are normally assume x and y will be parallel to the. So here in normal cases y we are considering as a vertical and x is considered as a horizontal, but in this fixed coordinate system x and y both are aligned to the earth surface, or it will be a parallel to the earth surface, and z will be a vertical direction. In a vehicle coordinate system, which is based on vehicle axis system, which is a movable one, the origin located at the vehicle reference point. How that vehicle is going to stand, and how that vehicle will going to be rotate, and how that vehicle will going to be placed on the earth system. So it is fixed in the reference frame of vehicle sprung mass, so that x-axis is horizontal and forward with the vehicle at rest. X-axis is horizontal. It is parallel to the vehicle longitudinal plane of symmetry, and y-axis is perpendicular to the vehicle longitudinal plane of symmetry. Okay, Z is left with the Z axis point upward. Z is constant. Only changes are related to X and Y. Okay, you can see over here. This is X Y Z system. X Y Z system here. That X Y Z system is related to that Earth coordinate system, and then this XV, YV, and ZV. It is related to that moving coordinate system or the vehicle coordinate system. It will be changed according to the that vehicle condition, vehicle running condition, vehicle moving condition, and etc. Okay. Now, when we are considering that wheel for attaching the electric vehicles, we need to consider these parameters like primary angle. The primary angle are the uh, basic angle align of the wheel relative to the each other to the car. In afternoon session, I'll tell you what are the different types of tires that we can consider for the electric vehicle, and according to those tires, how it is going to be adjusted. All this terminology like camber, caster, and tour. So, whoever the person involving in the automobile sector, they know the terminologies like camber, caster, and tour. So, on some car, not all these can be adjusted on every wheel. Okay, so there are different types of car terminologies has been given in that simulation software, like magic tire, then normal tire, and accordingly. So this will be completely justified or completely elaborated during that practical session. These three parameters can further categorize into front and rear, with no caster on the rear, typically not being steered well. And summary of this, all these parameters are like when we are saying front, then caster left and right, then front camber left and right, front toe left, right, and total. Then rear, the camber will be moved left and right, and rear, the toe will move left, right, and total. Now, these are the secondary angles. Secondary angles, it means ki how those tire will going to be moved according to the what we can say axle that steering direction and according to the driver operations. So the secondary angle includes numerous other adjustments such as steering axis inclination, ki how those steering will going to be more left or right like that. Included angle, which is in angle of left or right, then toe out and turns, maximum turns, toe curve changes, track width with differences, wheel base differences, etc. So frame angle, rear angle, and setback angle. So all these angle we're going to see in the afternoon session where we will see those actually the tire conditions. Now, excuse me. Okay, so the most what we can say the important topic for today's discussion is related to this battery. So when we are saying we need to discuss the recycling or degradation of battery, so before that we need to analyze what are the different types of materials which are being used for making those batteries. So if we are considering with the lithium ion battery, so most suitable solution is most suitable metal which is being used for battery is a lithium. If you will go for that periodic table of chemistry, you can see there are number of options available also for lithium. But there's a vanadium is there, uh, and there are different those kind of metals. But whether we get those materials from the earth or whether it is easy to get captured. So on that basis, lithium is being used. We can use vanadium as well for making a batteries, but whether we have that much storage of that vanadium, so that is a point of study and point of research work. So not to increase the sentence, I'm just focusing on what exactly different types of material which are being used in for electrical vehicles battery manufacturing. So first is lithium. As we have discussed, India does not have that much energy storage, that much amount of lithium in which will satisfy the customer needs of all Indian locations. Okay, only 1600 tons of lithium reserve were found in Karnataka that I had told you yesterday. And Geological Survey of India, then NREL, then there are different types of government agencies also. They are focusing on capturing more and more amount of lithium from the what we can say the cities where we are from which we are going to be get more and more different types of metals like MP, Andhra, Chhattisgarh, Jharkhand, etc. So for lithium, next is cobalt. Okay, why cobalt? Because from if we can make more dependency on cobalt, cobalt is a very rare material actually. It is also a very rare material metal which can be captured, but by some suitable reactions or by some metallurgical treatment, we can capture that cobalt from lithium as well. So, but if we will go for some good solution for cobalt, we can reduce the dependency on lithium-ion batteries. So, cobalt is trying to be acquire lithium and cobalt mine abroad. Okay, so hello, yeah, okay. आवाज येतोय ना माझा? Sir, am I
Yes,
audible?
yes, Sarita.
Yes,
Yes,
sir.
sir. Yes, sir. Yes, sir. Okay, thank you. So, cobalt. India is trying to acquire lithium and cobalt mine from abroad. One of the name, as I told you yesterday, that Bidesh Khanij Yojana. So under that Bidesh Khanij Yojana, we are making tie-up with other countries who are not rich in actually in lithium, but they are having a sufficient amount of lithium so that it can fulfill the demands of India or Indian Asian or Asian countries. So the suitable option for lithium is cobalt also, but China has already taken all the lead in this race because the most what we can say rich country for lithium, cobalt, etc. It are Chile, then Ghana, and those kind of African countries. But China has already captured all those countries and they have taken over on that. So we have to focus the other countries like South America, Australia, where we can get more lithium from that side. So India is actually working on that, and some amount of cobalt has also been found in Jharkhand, Nagaland, and Madhya Pradesh. So we are working on that. Nickel. India imports nickel from China actually. Okay. UAE, US, Saudi, Switzerland, Iraq, Australia, etc. So because nickel can be used to make nickel batteries or nickel bromide batteries, but as we have seen that comparative with the comparative analysis, nickel is not a fruitful solution to replace lithium. But if the lithium battery price will go increasing day by day, definitely we'll have to stick with some different solution, that is nickel. So nickel can be normally right now we are importing it from some foreign countries, but we can find it in Nagaland or Jharkhand kind of states. Next is manganese. Manganese is also a suitable material for making a batteries. Graphite, which is used in like a anode material for lithium-ion batteries. So we can find out the more suitable solution to replace this graphite also. Now, the new battery technology uses lithium metal anode. Okay, uh, earlier that graphite has been used as an anode material for lithium, but new technologies they are using lithium metal on the anode that could make the battery lighter while being more energy dense. Energy density will be the same, but battery will be lighter in weight. Less weight and higher energy density means a longer driving range for the vehicle. And the batteries, battery is a hybrid that does not use liquid in the cathode with drying coating on the lithium metal anode. Okay, here when we are going, this is a new modification for lithium ion batteries. When we are using lithium metal anode, so it will replace the liquid electrolytic solution in the lithium ion battery. When this liquid, we are replacing this liquid metal solution, definitely we are reducing the chances of explosion or getting a fire. That will be a good solution. Second is solid state battery, SSB battery. This technology includes higher cell energy density by eliminating the carbon anode, lower charging time by eliminating the need to have lithium diffuse into the carbon particle to conventional lithium ion cell, ability to undertake more charging cycle and thereby a longer life. If we are as on the above discussion lithium metal anode, the similar technologies like solid state battery, here solid electrolyte will be used in those battery, and using this the charging and discharging cycle can be improved. Lithium battery require huge amount of rare metal like cobalt. While designing or while manufacturing those lithium ion battery, huge amount of cobalt is required. This cobalt, we have much dependency on foreign countries like China and US and like those countries. But work is actually going on how to capture this cobalt from the seawater, because if we those who are related to metallurgical background or chemistry background, they know that around one not 1 billion, around 180 billion tons of cobalt storage is hidden in the seawater. And we can see, we know that we are just surrounded by many different types of seawater, or those kind of Asian or Pacific seas, all over around. So if we can find out some fruitful solution from this seawater, we can recapture that cobalt, and using that cobalt, we can reduce the dependency on lithium. More dependency. We can't directly replace that lithium, but we can get more amount of cobalt that will be helpful for manufacturing of lithium ion batteries. Next is silicon. Silicon as a energy dense material. It is or completely replace conventional graphite anode. So to replace the graphite, we can use silicon in the lithium ion batteries. Now to replace lithium ion battery, zinc will be a very good solution, because we India is having some storage of zinc. So by using that zinc ion battery, which can be a alternative solution for lithium, we can do this. And the best news for our India, that which is our friendly country, that like Japan, there is a number of storages of zinc, so that we can take zinc from them, and we can make some fruitful solution for batteries. See, zinc batteries are scalable alternative to lithium ion. Zinc ion batteries may differ in a safer, it is also safer, cheaper energy storage option, because it is less costlier than lithium. Scientists in Japan are working on new types of battery that don't need lithium like smartphone batteries. This battery will be a sodium battery. So sodium can be a very good solution for making a new battery. Lithium air cell. Lithium air cell, a concept that can pack in much more energy per kg that current lithium ion batteries. Long lasting, efficient, rechargeable devices. Lithium air cell, that is that pouch kind of batteries, which I told you yesterday, which I shown you yesterday, that silver color battery was there. So we can, using that silver, that those kind of batteries, we can pouch cell batteries. We can either compact the size as well as improve the efficiency parameters of the lithium ion battery. That can be a good solution. Next, the graphene aluminum ion battery cells. So charge up to 60 times more faster than the earlier lithium ion batteries, and hold 3 times more energy than aluminum based cell. So graphene, it is not a graphite actually. Graphene offer high electrical conductivity than lithium ion batteries. So many scientists are working on this graphene to get replaceable solution for lithium ion batteries. Yeah, this is somewhat quantum glass batteries. This is not actually implemented in many countries. It is in a working condition or research area actually. Quantum glass battery. Electrolytes have higher energy density and can deliver an equal amount of power to lithium ion battery in a smaller space. Quantum glass battery don't catch fire, which means they don't need components like lithium ion batteries that prevent them from starting a fire. Quantum glass battery also charge faster. Okay, so these are the some kind of glass batteries. Actually, from one of the research paper I had taken this. Actually, very less data has been given on the website also related to quantum glass batteries. So it is in under working process. Next is, as I told you earlier, that using our periodic table of chemistry, we can find out some solutions which can be replaceable to a lithium. So as lithium is in I think fifth table of that periodic table. So in that element, whatever the lithium, vanadium, those material we can use. So sodium working is also going on there. But vanadium also can be used to replace the lithium ion battery, but we need to identify the sources of vanadium where we can get more amount of that particular material. Aluminum battery, as sir also has told us yesterday, that working is going on aluminum battery because aluminum is having very cheaper, very light in material, as well as its storage are much more in India. So we can go for aluminum batteries like Asian countries. So these are faster than aluminum batteries. Sorry, lithium ion batteries, aluminum batteries. This is because they exchange 3 electrons per ion when recharging and returning to the negative electrode in the battery. The same anode and cathode reaction. Lithium ion can only move one at a time through the battery and recharging. So it is aluminum battery, we can say, a much more faster solution for replacing the lithium ion battery. The benefit of this material over lithium is that its stability. And this makes for safer battery with fast charging time and a denser energy storage system. Aluminum. There are number of advantages of aluminum batteries compared to the lithium. So we can move ahead with the aluminum batteries, which can be our future of battery, we can say. Now, as one of the fellow has asked me yesterday, how to dispose the battery. So actually, disposal of battery is next to impossible because either we have to destroy it using some higher temperature reactive, or either we have to keep it in some earth surface. But definitely when we will keep it in earth surface, it will destroy that the nearer area, or that quality of the sand or quality of that earth area. So we have to finalize some fruitful solution. So for that, some metallurgical engineer are working on it. Those who are aware about the metallurgy second year syllabus. So in that metallurgy, there are three different types of terminology were incorporated during syllabus implementation, like hydrometallurgy, pyrometallurgy, and electrometallurgy was there. So using those technology, normally these terminology, hydrometallurgy, pyro, and electrometallurgy, are used to capture the metal from the ores. But the same methodology using that leaching process, which is used in that electrolytic method, we can capture, or we can regain the metals of that lithium ion batteries. Like we can't completely destroy that lithium ion battery, but whatever the element or whatever the inside material or metals are being used while manufacturing that lithium ion battery, we can recover those metals, so that further it can be, and remaining whatever the stock or whatever the remaining material of that lithium, that can be destroyed in the earth surface while making the roads or those kind of areas. Now see, one by one, most of the battery that do not get recycled undergo high temperature melting and extraction or smelting process similar to one used in mining industry. So the same, that hydrometallurgy, pyro, and electrometallurgy. So basically here, for destroying the or recycling the lithium ion batteries, electrometallurgy process has been used. It is like a electrolytic process where we are degrading some one material using some chemical reaction to the another chemical material, and we can extract that metal using that leaching process, and or that what is that process, like screening process, and from that we can get the material which are like cobalt is there, manganese also there, graphite is also there. We can recapture those material, can extract valuable element from discarded batteries, and could potentially help reduce the amount of electronic waste ending up into landfills. Next, what are the different processes? As I told you, the first one is a mechanical processing. In the mechanical processing, the lithium-ion batteries are first disassembled completely, and with proper care, because it is actually discharged, but there are chances of getting fumes or kind of a fire. So that's why we need to, with a careful instruction and careful working, we can mechanically process those batteries, treating during the mechanical process, which enable to recover plastics, aluminum, copper, and black mass. The battery's black mass containing critical metal is collected and then taken for hydrometallurgical process by screening or leaching process to get another material like cobalt and graphite, etc. And this other material like plastic, aluminum, copper, which are being used for either covering those metals or those batteries, there it can be used further. So this is a kind, this is actually, this is not a disposal, we can say. This is how we can recycle. It is not actually a disposal. So hydrometallurgical process, that's why earlier I told you that disposal is very difficult or is next to impossible. Hydrometallurgical processing. The hydrometallurgical recycling process involves chemical precipitation methodology, like screening process, or that what we can say, we can use the word charni process, like that. Okay, that chemical precipitation methodology that allows scarce mineral to be recovered from the black mass and delivered to the battery manufacturer for reuse for the new batteries. Lithium-ion batteries contain material like that can be recycled with the right process. Processes are very important. Recycled material include metal compound, ferrous metal, aluminium, copper, graphite, cobalt, etc. All those can be recovered. Now, recycling technologies of waste batteries. Now, as I told you, many scientists are actually working on this, that how to recycle and how to do this processes. So actually, the whatever I had discussed, whatever that I had discussed here, the same thing with different technologies has been different, like which country will use what kind of technology for recycling the battery. According to that, it has been justified here. The first one is incineration and landfill. So same, that whatever the amount of material we can recovered from the lithium ion battery, let it recovered, and whatever the wastage part has been taken, use it for making a road surfaces or those kind of working area. Some battery will burn after they are discarded, but this will produce a lot of dust and tiny particle to pollute the atmosphere. Some battery are buried in the soil together with municipal solid waste, but this require high improvised measures. Otherwise, it will be very easy. It is very easy to cause serious pollution to the soil. So, therefore, by taking a proper care, initially discard all the battery, and then whatever the material, whatever the metals we can recapture from those batteries, let it capture, and remaining material used for burying in the soil to make a road surface. If we will directly use those batteries without taking those metal, without extracting those metals, and then we will bury those battery for making the road, definitely that will impact on the soil quality. Next is curing treatment method. The solidification disposal method. Curing treatment method is actually a mixing of waste primary battery with concrete ingredient in a certain proportion after crushing, and then mixed concrete is used to for paving the road or mixing with other building materials. So this method has three advantages. First one is to save the raw material of concrete. Definitely, this all raw material of the remaining battery components that can be used for construction material, construction fields also. As I told you that road constructions also. So, other to improve the quality of the concrete by using waste battery, and third is to reduce the pollution of waste battery to the environment due to characteristics of the concrete. Definitely, for construction field, that can be, we can recover those battery materials and we can use it. Whatever the metal we need for new battery making, let it be extract, and remaining metal we can use for construction field. Next is wet recovery technology. This is actually hydro metallurgy, wet recovery technology. Wet recovery technology is mainly to break the batteries after fully discharged, make it and then leach them with the acid to produce a soluble salt solution. It is like a somewhat a chemical reaction. With some acidic solution, it will going to be act, and after that we can recover some material like cobalt, nickel, and lithium by ion exchange process. It is somewhat similar to chemical reaction. So it is like a hydrometallurgy. Break the batteries, and then using that leaching method, we can extract the metals. Next is chemical precipitation method. It is also somewhat extension of that hydrometallurgy, where chemical precipitation method is to add precipitate solution to cause precipitation reaction, chemical reaction, using suitable chemical reaction agent to find out the cobalt and in some cases nickel, or in manganese also, or graphite. Solvent extraction. Solvent extraction is a specific organic solvent to form a stable complex with the metal ion. Thus, it will selectively separating valuable metal ion to extract the cobalt. In short, all those terminologies, all those above methods has been used to extract the cobalt from the lithium. Next is ultrasonic method. In ultrasonic method, because in ultrasonic leaching method actually, the mechanical effect, cavitation effect, and thermal effect and chemical effect of ultrasound, high temperature and high pressure can be produced very short time and very small space, and the high temperature change rate use ultrasonic to improve the leaching rate of cobalt. So that ultrasonic method is actually that solvent extraction, but solvent compared to the solvent extraction, that cobalt can be extracted with the more amount of time, but with ultrasonic method it can be recovered fast. Dry recovery technology. In dry recovery technology, mainly uses physical method to break the battery after fully discharged. Like mechanical method. For that, we need to take much care and and we need to go for a mechanical testing as well, and get the final product through a series of oxidation reduction processes. Final is a fire method. Fire is just burn it using that electrolytic reaction or electrometallurgy. Recovered waste lithium ion phosphate battery can be recovered by pyrometallurgical reduction roasting method. Okay, so electrometallurgy process also we can involve in fire method. Pyrometallurgy also we can involve this in fire method. Okay, so see, the electro material was treated in nitrogen flow at 400 to 600 degrees Celsius for 30 minutes. The new battery was reconstituted by adding binder of the stearin butadiene rubber and sodium carboxymethyl cellulose to find out the then next fruitful solution to make a more battery efficient solution. Mechanical separation method. There are two kinds of mechanical separation method. One is to remove the battery shell and then break up, screening separation. The other is to directly break the whole battery, skinning the separation. But it is very mechanical separation method. Biometallurgy can be divided in bio-leaching, bio-oxidation, bio-isosorption, and bio-accumulation. At present, bio-leaching is the main method. Okay, the metal components are usually separated, extracted by bilateral oxidation or biological oxidation, simply oxidation process, such as the treatment of spent nickel hydrogen batteries with acidophiles and other metalloids. So that it will impact in very less chances on the environment as well, and on human beings, etc. Now, okay, so overall, we can say for complete recycling of the battery is not possible, but we can recycle some component of those batteries using pyrohydro or some metallurgical processes, some chemical processes, and some biological processes. Now, where this IoT stands in electrical vehicles. So we can see when we go to the petrol pump for fueling the petrol in the vehicle, in a very rare cases that we are directly getting that vehicle fueling station with a sudden time. There is a long queue is there, and after that long queue we have to wait for much more time, and then we will get that petrol or that fuel. But let us assume that in our mobile there is a smart system like which is a nearer petrol pump for me, and as in that many apps of that food transportation or those kind of which that app is there, like a Zomato app. In Zomato app, we can see to get a food from some hotel, we identify which is the nearest hotel for me, and then what are the ratings and what are the different types of prices or etc. Okay, so the same terminologies can be implemented for refilling the petrol also. If we have some kind of app like which is a nearer petrol station or to me, and where there is a long queue, so we can identify whenever wherever there is a small queue, or we can easily get the petrol, we will go to that location and we can find out the fruitful solution. The same terminology or the same technology of that app or making app or the liking that internet of things, we can implement in this electrical vehicle. You can see here, EV charger station becomes smart, connected, and hence easily inaccessible for remote support and maintenance. Like during EV integration also, we have seen that using IoT in the future technology, we can more modify that EV integration into the system. With the IoT powered charging apps, like driver can easily search for a nearby station, scheduling the time to fill up or to charge the battery or to charge the electrical vehicle. IoT platform can also be a comprehensive solution for complex EV charging station control, uses and management. It connects various distributed engineering devices and manages them within one network. It is not. I'm not saying that IoT will be used for only charging. Identify the charging station. We can implement that IoT into the that data acquisition system or a sensory mechanism as well. We can connect the IoT system to it, and we can run the complete electric vehicle using IoT technology. Many times, maybe you have heard that driver is just sitting on the chair, sitting on the seat, and by folding hand and not moving that accelerator or that steering. Still, just by oral instruction, telepathy instruction, he can move the vehicle. Okay, that vehicle, it is AI technology, but it uses this IoT technique to implement it. Okay, so there are number of electrical vehicles. It is actually a future where driver will just sit with the folding hands, and he will just going to give instruction to the vehicle, and like just by telepathy instruction, that vehicle will move further with good efficiency, maybe without accident and etc. Okay, so we can using IoT, we can connect all those components of that electrical vehicle. That is, I want to say from this sentence. Data collected from various devices are processed and analyzed by advanced data analytics system, like advanced data analysis system. One of the site has been working on it, msts.iot. So this website actually, this organization actually working on it, how those techniques have been implemented for data collection in the sense that whatever the data related to fuel system, data related to that charging, data related to whatever the batteries, fuel, etc., that can be collected and that can be further used with the good efficiency. IoT can also be applied to electrical vehicle charging station. The same sentence has been repeated. IoT perform use advanced cloud computing. Actually, so cloud solution that allows collect, analyze data in the real time. Okay, you need not to carry all your data, all the data, either it is electronic data, programming data, whatever the data related to that electrical vehicle system, with the kind of a drives or kind of storage that data storage devices. We using IoT techniques, we can implement the cloud data in the electric vehicle, and that cloud will be everyone aware about the cloud data. So that cloud data can be further used in future as well with the internet solution. Yes, definitely, internet is a compulsory thing for it. Yeah, significance, you can see from the figure significance of IoT. This IoT system can be used to control the EV parameter of the battery, like which are those, like current, power consumption, voltage, whether that battery will going to be filled by the so flammable gas solution, or payment and billing that can be done by just clicking on the app, and payment can be done. Wireless sensory network that can be used for to reduce that wiring connection inside the vehicle as well. Hmm. Mm, the same number of terminologies which we have discussed, that has been given over here, so we are not going to repeat it again. Hmm. You can see over here, Now we are moving towards 5G technology. So this internet technology will going to be improved day by day. Maybe in future it will be 6G or 8G. So accordingly, that electrical vehicle will going to be improved. So in maybe in you have seen in maybe many foreign Hollywood movies, that James Bond and those kind of movies, we can see if that person is getting some kind of a heart problem or any kind of medical or health issue. Uh, that using that vehicle, he can communicate with the person or with the doctor as well. So using and that was actually IoT technique. So the same IoT technique we can implement in our electrical vehicle, future electrical vehicle as well. uh, so that whenever that driver will feel a problem and he need some doctor or some health issue he is facing, so that data directly that person should be in a condition to communicate with the either nearer doctor or nearer hospital. Sometimes if that electrical vehicle are getting into contact with the accidents or those kind of things, so directly message of that accident should be reached to the nearer police station or the family members of those persons. So there are numerous advantages of implementation of IoT into the electric vehicles or any kind of normal vehicle. So if we can inbuilt that IoT system into a vehicle, whether it can be a two-wheeler, four-wheeler, or whatever, so we can have a tremendous or huge amount of advantages for our human purpose. Some benefits of integrating BMS with the IoT. Now, as I told you, the BMS is a major important factor of battery pack. Key to identify the overcharging issue or less charging issue or balancing issue, controlling the balancing issue, and what I can say that thermal runaway problem. Now, how this IoT can be implemented? BMS is actually electronic component, and to connect that BMS with the IoT, it will be a very easy and it will be a very strong, efficient solution for the electric vehicle. It is if everyone is aware about the digital twin. So mirror framework, it is actually of processes and functions of car is treated on the cloud or edge. Okay, sends updated data to the car driver about battery parameters, initiate system warning in case of any kind of anomaly. If there is a sudden change of voltage, sudden change of current, higher capacity is going to there, so that message will going to be reached to the vehicle driver, so that he can control the speed or distance, or he can control the vehicle. Then battery diagnosis is possible. Cell balancing can be easily done. Data collection and processing can be done. Maintenance of the battery maintenance can be improved. Then theft issues are yes, that is the biggest advantage of this IoT technique. Theft issues can be reduced. So in this way, that IoT can be a huge huge it will play a huge role for modification in the electric vehicles. Now, there are three category of types of fast charging actually. So these are trickle charge, AC charge, and DC charge. So trickle charge is actually the slowest method of charging in the at home using standard 220 volt plug. So this trickle charging is actually used by this current nowadays electrical vehicle manufacturer at whatever the example we have discussed at the start of the session, that charging cable will be or charging facility will be make available to the in the parking area by those manufacturer. So that is actually a trickle charge. AC charge, having a wall box install, let you to charge 3 to 4 times faster using AC household charging. So this is what we can say the intermediate solution between trickle and DC charge. So the most fastest way to charge it DC charge. So because DC charge at a public DC for charging station with power from 50 kilowatt and above. With this method, we can top up the battery charging 20 to 80% in 40 minutes. Okay, so research is going on actually how this 40 minute can be reduced to 30 or 20, and with the same efficiency of the battery. Charging algorithm. Now, what are the different types of charging algorithm where we can work? The constant current charging method adjust the output voltage of charging device or the resistance in series with the top battery. So the first charging algorithm is constant current charging method. So in using constant current charging method, we can improve the charging capacity or the time taken for the charging of the battery as well. Constant voltage charging is also good, but in constant voltage charging will be good for higher capacity or where it required uh, higher current capacity applications. Boost charger. So boost charger actually not mechanism. It is how fast we can improve the boost charger, in the sense ki everyone is aware about that boost charger. Using boost charger, it is a further development at a constant current and constant voltage algorithm. It is a mixture of both constant current and constant voltage. Okay. Then multi-stage current charging divides the entire charging period into a several charging stages that attempt to use the optimal charging current. So this can be a combination of above charging methodologies or charging mechanisms. Non-contact charging utilizes a magnetic resonance. Okay, so without making contact of charging cable and vehicle, we can make possible for charging using some magnetic resonance methodology. Using that magnetism of that material, we can charge the battery. This achieves highly efficient energy transformation. So many times we are also thinking that without any kind of charger or cable, how our mobile can be get charged. Okay, so this can be a fruitful solution for this electrical vehicle charging stations also as well. Battery swapping. Battery swapping involves the use of automatic or semi-automatic system to exchange a depleted battery with fully charged one. It is simply like auxiliary device, like a stepney. Earlier, let us keep one charged battery with you, and then after discharging the earlier battery, just replace it with the new charged battery. Testing of lithium-ion batteries. This is quite a good area of work for the faculties as well. If they have a good setup at their college, they can do some further research work in this kind of situation, in this kind of area. Batteries will going to be implemented in the future, but how it will going to be test before implementing into the working area. So there are different types of NDT tests we can possible, but those NDT tests are possible for the limitation of 80 kilometer per hour vehicles only. Then dynamic loading and deformation of the high voltage battery structure using an impactor. So this is also a good area of work where dynamic loading can be done. Then altitude simulation, thermal test, vibration test, shock test, external short circuit test, impact crushing test, force discharge. There are numerous different types of tests are possible on this different types of batteries. We can't go in much detail about how these tests are being carried out. You can search on the website, but there is very less data actually given on the website as well. But if any person want in detailed data, they can contact me. I will share with them. Because for every test there is a long methodology and long processes are long steps have been given. Like let us say for battery cooling testing, there are different types of cooling methodology with different types of materials we can use for cooling system. So there are these types of tests which can be possible on right now I have focused only on lithium ion battery. But this test has been possible on the other batteries as well. But before testing all those batteries, we have to follow the IS standards suggested by the Indian government, or that those testing standards has been given in that I think AIS. Okay, we will discuss all those standards in the next slide, but we'll have to follow those standards. Okay. You can see here what are the different types of tests possible on the different types of battery. A comparative analysis has been given. For lead acid, we can go for voltage analysis test, ohmic test, that is current test, then a rapid test, battery management test, Coulomb counting. Coulomb counting in the sense ki calculating of number of charges, charge capacity of the system of the battery. Then for nickel-based battery, lithium battery, and primary battery, we can say primary battery in the sense that whatever the initial battery which are used, this can be a nickel battery, this can be a lithium battery, can be lead acid, this can be another types of battery which are being used in electric vehicles. Now, the final slide, or we can say the final terminology which we are seeing here, that is which are the different types of battery standards which we are going to follow for electrical vehicles. So, the battery standards are AIS 38 and AIS 48. Okay, there are a few new versions are also available of this. AIS stands for automotive system, actually. Okay. Vehicle safety standards. This now AIS 038 Revolution 1 2015. This standard prescribed the requirement only for construction and functional safety of electrical vehicles for L, M, and N category. Now, what is this L, M, N category? L stands for low category. Low category in the sense not low category electrical vehicle like two-wheeler or light cycle or two-wheeler, it's a moped bikes or kind of we can say three-wheeler, etc. So those are being categorized into a low category. Okay. Then second is the M means stands for medium category where normal four-wheelers. Normal four-wheeler in the sense ki lightweight four-wheelers which are being used by consumer for just for transport moving purpose from one location to another. N category stands for heavy vehicles. It is also N category is also for four-wheeler, but it is for heavy vehicle like trucks, buses, or those kind of vehicles which are used for transportation purpose. So this AIS 038 stand for this LMN category. Specification and during this AI standard, various tests has been followed like electric shock test, protection against direct and indirect contact like an impact test, and protection against water effect like whether it is getting a chances due to water and fire explosions are possible there, etc. Battery safety standard. This standard covered traction battery safety for LMN category, including e-rickshaw and e-cart. It mainly covered the following two types of testing. In this AIS 048 battery safety standard, this AIS 48 stands for battery safety standard, 38 stands for vehicle safety standard. So in this battery safety standard, they are going for short circuit test, overcharging test, mechanical shock test like an impact test, and rollover test, that is open types of battery not applicable for actually lithium ion battery. Penetration test, it is a rollover test means a penetration test. AIS 2020 version that where they are not going for only vehicle, they are going for vehicle plus battery M and M, but it is not applicable for L category vehicle, it is applicable for only M and N category vehicles. So the same all types of tests has been available here. Then AIS 156. For AIS 156, the new version is AIS 156 is new version for L category. Okay, so this standard prescribes the safety requirement with respect to the electrical power train of motor vehicle and rechargeable energy storage systems. Then AIS 108, AIS 102, it is applicable for four-wheeler with the mass not exceeding 3,500 and L category. So AIS 102, it is applicable for L and M category actually. AIS 102 Part 2, it is applicable for higher vehicle which is mass exceeding 3,500 kgs, like heavy trucks or what we can say buses, etc. So for those, this AIS 108 is AIS 102 Part 2 is applicable. Okay, so that's it from my side, and in the afternoon session we will going to see hands-on session with that forward methodology and reverse methodology for that simulation of electric vehicle. Okay, hello, Santosh sir.
Yes, sir. Yes, sir.
Okay, so that's end from my side.
Right. If anybody has a doubt or interact with, please, you may ask your doubts or you can interact. Yes.
Any development is there for the charging stations at the societies? housing societies?
Actually, no further development has been done. Only I have heard about one of the company Ola. So they have started that if you will book the car, the person will came from that side and they will go. They will implement that charging station at your parking area. So you need not to go for charging at some other location. That is only the charging system a development. But for fast charging, the working is going on constant current and constant voltage combination method actually at local charging stations.
No, nowadays most of the society are under redevelopment condition, and in that case they are going for the puzzle parking or stack parking. Uh, Everywhere you have to go for the charging point, and it is very difficult for the single charging point to the all the vehicles.
Yes, yes, sir.
Then anybody has developed a solution for that?
They have not developed actually, but they have started. They have taken the initialization by Ola.
Ola.
If you have the what we can say recovered parking or covered parking at your flat or society, they will come to you and they will give you a separate charging station to you. That will be applicable, and that electricity will taken from your society. But for that, government will going to implement new billing terminology in that our electricity bills. So there is some problems which are going to be sorted out, that taking permission from government authority and that society, and then we can implement that thing. But this will be possible only in cases where societies are quite strong, or the societies where solar system is already implemented. So that will be more fruitful solution for future, we can say.
Okay, or any card system will be there for the charging purpose.
Actually, I had not heard about that car system, but
Card.
card. Sorry, card
Card
system.
system.
Yes,
It's
card system.
debit or credit card system like this much or prepaid solution for that.
Yes, for that IoT methods has been implemented, are starting implementing that using IoT technology. If we can just by making a kind of a app key on like we are doing a cylinder booking or somewhat like some kind of
Yeah.
thing. Key. So using that IoT technology and artificial intelligence, one of the organization I actually done that MSMT, they are working on it.
Okay.
I think Arvind Godke, yes, Arvind Godke has raised his hand. Yes, Arvind. Arvind, are you there?
Yes, sir. Yes, sir.
Yeah, yes. Yes, you want to ask something?
Sir, I am trying to install MATLAB.
Okay.
So I am installed R2021B version.
Okay.
Whether it is feasible?
Okay, no issues, sir. After 18B and further version are very suitable for electric vehicle design. 18B and further.
Okay. Thank you, sir.
It can be anyone. 20, 19, 21, 22. It doesn't matter. But it
Okay,
will
sir.
affect your computer. What is the configuration of your system?
64-bit operating system
RAM.
and RAM is 4 GB RAM.
Sir, it will be difficult. Your PC will going to be slowed down. So
Yes, sir.
you have to improve it because yesterday if you attended my session, my computer is having around 8 GB RAM and
Yes,
i3
sir.
processor. Still I think this that process computer was slow. So
Yes, sir. Yes, sir.
so definitely you'll have to go for a good configuration computer.
Okay.
If you're
And sir, during installation, it will ask for a number of products. So, what are the benefit? What are the important products I have to select in that?
No. Just go on selecting each and every product, because we don't know which kind of component we will need for our structural design. Any component we can, because component during component sizing, any component we can need. Maybe it's because there are simscape is there, aerodynamical components are there, or Simulink is also there. We will work on the Simulink, but
Okay.
sometimes during construction of that Simulink model, we can need a Simscape as well. So you go on importing each and every component while installation.
But it will require more memory, sir. Then.
Yes, yes, sir. That's that is I'm telling, because my computer is having SSD 256 GB, and 100 GB has been taken by just by that's only one MATLAB software from this SSD.
Okay.
So,
Okay.
but I am my research work is going on actually in the same field. That's why I need that thing. I can't ran away from that thing. So definitely, if you are want to work in the same field or same future area in the same field, so definitely you have to improve your that infrastructure facilities also.
Okay. Thank you, sir.
Yes, sir. Yes, sir.
One thing I want to ask you, sir.
Yes, sir.
Why we can't go for battery swapping in at charging stations?
Battery swapping. Yes, sir. It will increase the theft issue, sir. Because if day by if in the future, day by day, if we will go dependent on just electric vehicle or battery, so definitely there will be theft chances will going to increase. So that's why, and there will be a chances of getting queue to replace those battery or swapping those batteries. You can see
Okay.
just by taking a stepney in the or tire in the four wheeler, and the tire will going to be punctured at some location. So it will take a much time to swap that or to reinstall that earlier tire with the puncture tire and etc. So to reduce the time and to reduce that theft chances, we are that solution is not better. Yes, that is a good solution, but it for longer run it will not be a better solution.
Okay. And I heard that the charging through Wi-Fi connections
Yes, sir. Yes, sir. It is
is
make.
research going on.
Yes, sir. Yes, sir. Yes, sir. Through Wi-Fi connection, because it is not a need of only electric vehicle. It is need of our system also. Because many times we can see that we are not carrying that charger with us, and suddenly mobile has been switched off. So
Right.
we can take that charge from some others mobile, that other mobile is 100% charge and your mobile is discharged, so we can take that charge from others mobile as well. So research is going on actually on that, but
Right.
we'll get some fruitful solution because but it will need closer contact between the two input and output, because there will be a magnetism, and there will be a flow of electrons as well, and flow of charge as well. It can create some harmful effect to the person who is in contact with it. So how to control that area of charging station, or sorry, that charging area. So working is going on that, but definitely it will be a solution for within 1 or 2 years. Definitely it will, we will give by modification in IoT and AI technologies.
Okay. Is there any further questions? Uh, Okay, all participants in the chat box, feedback link of this session is shared with you, all of you. Just fill it and submit it. I think Avsare sir is asking your contact details. Avsare sir, I have also shared Ravikant sir's contact detail in chat box.
Okay, I'll take it.
Okay. Okay. Okay, sir. Shall we conclude today's session, sir?
Yes, sir. Because whatever the discussion that I want to did for this today's session, that has been completed from my side, and I don't think there is a question from anyone participants, so we can
Okay.
conclude.
Okay.
And I think we have exceeded the time, so
Right.
let us meet at 2:15. 2:15 will be better.
Okay. No, not issue, sir. No issue.
So give the same instruction to all the participants. We will not meeting at 2 o'clock. We will meet at 2:15 because actually we
Okay.
have gone to 1 p.m.
Right, sure, sir. Because you are the most
No, no,
tired.
sir. Actually,
We are just listening you.
I don't have any issue, sir. I can start with the 2 p.m. also. I
No,
am
no,
just
no.
thinking
Sir
about all
will,
participants.
no issues. We'll start with 2:15 p.m.
Okay, okay, sir.
Okay. Okay, sir. Thank you very much. This was a very fruitful session.
Yes, sir.
Another fruitful session on electric vehicles,
Thank you,
and
sir.
we'll meet at 2:15 p.m.
Okay,
For the last session of our 2 days workshop.
okay, yes, sir.
Okay, then all of we'll meet at 2:15 p.m.
Okay,
Thank you, sir. Thank you very
okay.
much. Thanks
Thank
to
you very
all
much.
of you. Thanks
Okay, sir. Have a
for
good day, all of you. Thank you.
have a great day. Thanks.